This is problem number 7 from section 9.2. In this problem, they say, shade the region of feasible solutions for the following constraints. So they give you 4 inequalities here. We're going to graph all 4 of these and then see where the solutions lie. Now, because there's 4 of them, I'm going to graph them in different colors. So this is going to be a brown. I'm just going to put dots next to it. This is going to be red. We'll go with blue for this one here. And then finally, we're going to go with, what's a good color? Maybe a green. That'll work. All right. We need to start by taking the top 2 inequalities and writing them in slope-intercept form. So let's start with the brown inequality. And we'll say that x plus y less than or equal to 6. We're going to subtract the x over. So it's y less than or equal to negative x plus 6. This is the y-intercept. This is the slope. Now we're going to take the other inequality and we're going to rewrite that in slope-intercept form. I forgot to write slope-intercept form up here. It's y equals mx plus b, but we should already know that. So we're going to now take x plus y greater than or equal to 1, subtract the x over. Y is greater than or equal to negative x plus 1. This is the y-intercept. This is the slope. Now the other 2 equations are pretty easy to graph because x greater than or equal to 0, that's a vertical line. So I'm just going to write that here. This is vertical at, well, I'm not even going to put the at. So it's vertical, a vertical line at x equals 0. And this is a horizontal line at y equals 0. Okay, I think we're ready to graph. So let's draw this graph. I'm going to draw it pretty large actually this time. And we're going to mark it, y-intercept is 6 there, so let's mark it at 6. So 1, 2, 3, 4, 5, 6. Try and make them all even. All right, now that we have them all marked, let's go ahead and mark the y-intercept, which is 6. So 1, 2, 3, 4, 5, 6. We can go down 1 over 1. So down 1 over 1. Down 1 over 1. Down 1 over 1. And we're going to do this until we get all the way to the x-intercept. And we're going to say that this is less than or equal to, so it's a bold line. And they say to shade less than or equal to, that's underneath here, but we can check it. So let's go ahead and check that. We'll say check 0, 0. When we do that, we get 0 less than or equal to negative 0 plus 6. 0 less than or equal to 6. That's true, so yes, shade towards. So we're going to shade this direction. Let's graph the other one. So we have y greater than or equal to negative x plus 1, so plus 1 is here. Down 1 over 1. Down 1 over 1. So we're going to go ahead and mark that. It's a bold line. Just like so. And it says greater than or equal to, which means shade this direction. We can check that by saying check 0, 0. And we're going to say that that's 0 greater than or equal to negative 0 plus 1. So 0 greater than or equal to 1. That's not true, so no. Shade away. So we're going to shade this one this direction. Last 2 lines to graph are the easy lines to graph. We got a vertical line at x equals 0. That's just the y-axis essentially. So we'll go ahead and just mark this blue now. And it says greater than or equal to 0. So x has to be bigger than or equal to 0. That's shading to the right because that's where the x values are greater than or equal to. Again, you can check. You could check like instead of 0, 0 because it says greater than or equal to 0. Check like 1, 0. And if you plug in 1 for x, yes, that's true. So it goes this direction. And then finally, we can do the y greater than or equal to 0. That's just the the x-axis. So we'll draw this in green. And we're going to shade that one. It says greater than or equal to 0. So that's shaded upwards. Now, where do all these things meet? Well, first of all, these two are shaded towards each other. So we know their shades are in here. This is shaded to the right. So that's got to be, this is the line that divides them. So it's now just shaded in here. But this is shaded upwards, so it's really all just shaded right in this area. So we're going to go ahead and mark those solutions. I'll mark them in black. How about that? So the solutions lie right here. And that's how you find the solutions for, in this case, multiple constraints.